Hello. So I'm going to work on a couple of problems that came across my desk. There was a um, kind of an ask my professor question that came in, and then also there was a question about the quiz, a few of those problems. So the first thing I'm going to look at is let's do the ask my professor question first. Let's take a look at that. So we're given this uh, data set. There's two variables, so it's matched pairs. And so we're able to create a scatter plot based on this data. The following data represents the number of calories per serving and the number of grams of sugar per serving of a random sample of high fiber cereal. The problem with this is the sample is somewhat small. And so because the sample is small, we will have to use this table of critical values as a guide to determine whether or not our correlation coefficient is good enough. Um, Basically, the R value is the correlation coefficient. And so if you look at the table, if your sample size is on the left side, then you need an R to be more than this in order for you to have a correlation between the two variables. Um, so depending on the size, obviously the smaller the size, the stronger R that you will need. Our sample size looks like there's only 5, so we're going to be looking at a critical value of 0.878. And if our R is greater than 0.78, 8.878, then that lets us know that we are, in fact, have a linear relationship. Now, the first question, a scatter plot, what type of relationship exists based on the scatter plot? And this looks like a cloud formation. It's somewhat horizontal. If you were to try to draw in a line that will kind of equally go through all the points, straight line, it would be more or less horizontal. And it does have that cloud formation as well. It's neither positive nor negative, so it's safe to say based on that there appears to be little or no relationship. There's other ways to graph this as well. So we could open the data in StatCrunch. Let me see if this works. Hopefully it does. Oh, it didn't work. Okay, that's odd. I may have to just literally log in to StatCrunch, because I think at some point I'm probably going to need it anyway. So let's go in there. But the next question, let's move on. Part B, determine the correlation coefficient. So now they actually want us to, and the way we do this is either using your graphing calculator or StatCrunch. Here's StatCrunch. I've logged in, open it. And now that it's open, maybe I can open the data to it as well now. Good. Okay, there's my data set. As you can see, we have 5 observations. And I can go to Stat. I could go down to Regression, Simple Linear. Choose the X variable as calories and the Y variable is sugar. That's all you have to do at this point. Hit Compute. And they give us all the stuff that we need. If I hit over, it even plots a nice scatter plot. It looks different from the one that was given because the scale is probably different, as you can see. It's more zoomed in. But if we go back, we can see that the correlation coefficient, the R, is 0.07. That is extremely small. It's very close to 0. And remember, 0 means no relationship. So let's go back to that question. This looks correct, okay? The correlation coefficient is 0.07. Determine the critical value of the correlation coefficient. Well, the critical value for when we're dealing with 5 members in our matched pair design, you need to have an R of 0.878 in order for there to exist a correlation. We just have such a small sample, so in order for there to be a relationship, we have to have a somewhat very strong R. And that R is the absolute value. It could be a negative 0.878. We are way off. We're at 0.07. So is there a linear relationship? And since it's less than the critical value, and that is the critical value, we call it the critical value because it separates the good from the bad. It separates positive relationship versus no relationship, and so therefore it is a very critical number. And the correct answer would be no. Suppose that we added another cereal, which is 50 calories and 3 grams, to the data, redraw the scatter plot. Well, if we were to do that, we could just pencil it in. I mean, we're talking 50 calories and 3 grams. That's going to be an outlier too, by the way. 50 and 3, we probably have to rescale everything. So it's going to be the somewhat same shape, but the other point is going to be kind of way off. So we're looking at 50 calories and then slightly up. So that's just a matter of figuring out how to read the graph. These two were very, very similar. But the problem is that we have sugar on the left, and here we have calories on the right. It actually should be sugar on our horizontal and calories on our vertical. And so that's what's wrong with C. Other than that, C would have been the right answer. So I think we just kind of got tricked. Recompute the correlation coefficient. Well, what we could do is go back into StatCrunch. And we're just going to add that value in. We'll do 50 calories for 3 grams of sugar. And now we're going to close this out and just recalculate it. We go back to Stat, go to Regression, Simple, Select, Compute. Our R has jumped up to 0.8584. All right, it depends on how they want us to round it. Probably the 3 places. Let's see. Yep, they said 3 places. So I'm going to say 0.858. And that's going to do it. Now, determine the critical value for that correlation. Well, the critical value has changed now too because we now have 6 observations in our study. We don't have 5 anymore. So that does change a few things around. We pretty much have to just click on the table. It's just this time we're dealing with an N of 6. The critical number is 0.811. And guess what? Our R is more than that. And since the R is more than that, we can go on and say that there is going to exist a relationship now since it's greater than the critical value. All right, since the absolute value of the correlation coefficient is greater than the critical value there, all right, hold on. Okay, yeah, this is the one. There's one more choice, yeah. And that's going to do it for that question. Now, there was another question that came in, and this was dealing with the quiz question. So let's peek at that. Let's go in there and do that quiz real quick. I'm not. Oh, wait. Let's see here. So I'm gonna have to literally go inside and into access it now, which is not a problem. Um, this was a This is a pretty important topic, actually. Determine the area under the standard normal curve that lies to the left of this. And we're talking standard normal curve. There's a lot of support on this. If you go into discussions, I'm sure I've done quite a lot on these type of questions on 7.2. Let me demonstrate where that would be. If you go into discussions, you go into random homework problems, look for something for homework 7.2 like this, maybe some of those. So there is some support out there for this. Determine the area under the normal standard curve to the left of this. So the first thing we should do is take a look at what this looks like graphically. The standard normal curve is this bell-shaped curve such that the mean is 0 and every deviation is 1. And they want us to find the z to the left, the area to the left of negative 1.4. So we could say approximately here. And we're trying to locate all of this area. It's not going to be much. There's a few ways to do this. We could use our calculator or we could use StatCrunch. StatCrunch is available for the test. You should be able to access StatCrunch. If you want to look at how this is done on the calculator, you basically need to go to your calculator. You go over to distribute. All right, this stands for the distributions that we deal with in statistics. There are different types of distributions based on our data. And so we're dealing with the normal CDF for this because we're going to be calculating the cumulative density under the normal bell-shaped curve. And so number 2, normal CDF is our guy. We have to have a lower bound and an upper bound. The lower bound, as you probably noticed, was unbounded. So we just got to put in a very tiny negative number. Like negative 100, negative 10 would do good. So I'm going to put a negative 100, probably even more negative than that. This one was negative 1.49. Actually, let's go up one. Negative 1.49. Now, the mean is 1, the standard deviation is 0, because guess what? This is the standard normal bell-shaped curve. Okay, so we put in minus, but technically it should be the negative button. That minus sign just looks too big, doesn't it? So we're going to delete that out and then insert a negative there. And the same is true for this one too. Alright, so now, let's see here. Alright, 1 second. It should be the other way around. The mean should be 0. And the standard deviation should be 1. There we go. So we're getting 0.068. Let's make sure. Did I get negative 149? Oh, it's negative 148? Alright, that does make a difference, so we need to change that as well. .0694. What about the area to the left of that? So we could just do a second entry. Change negative 1.48 to 84. We're getting 0.200. .2005, actually. We can round it off to 5. What about the area to the left of this? What about the area to the left of that? These are all straightforward. Nothing too crazy. It gets a little wild when they start talking about the area to the right, the area in between. That's where you kind of have to know what you're doing. We could pull up StatCrunch. It's under calculators, and it would be under the normal calculator. And here the mean 0, that's standardized. We're looking for the area to the left of this number, so we could put in, let's see, the other one was negative 1.32. So let's put in negative 1.32, and then just hit calculate or compute. And this looks reasonable. This looks right. The area to the left of negative 1.32 is 0.0934. And then negative 1.69, we could do the same thing there. Okay. We could change this. Let's see. Zero 455. We're done with that one. The 13th percentile. So we're trying to figure out what day would be in the 13th percentile. That's pretty low. we know the mean. Is 21 days. The standard deviation is 1 day. We could set this up. This does follow a normal distribution, not the standard normal distribution, but it does follow a normal distribution. Okay. Again, the mean is 21. Standard deviation of 1, so that would be 20, 22, 19, 2 deviations away, 2 deviations away, 23. And what they want us to do is determine the time for the 13th percentile. That is the lower 13%. So we're basically need to shave off this amount of area represents 13%. We need to figure out what the x is. What number is it that will give us the lowest 13%? So we don't do normal CDF. We do the opposite of normal CDF, which is inverse norm. Normal CDF is when we have the bounds and we need to find the area, the percentage or proportion. Inverse norm is when you have the proportion and you're trying to find the bounds, or in this case, just that one x value. So we do inverse norm of 0.13, comma, the mean, comma, the deviation, and that's it. Here, we could do it here as well. We could just say it's 21 and 1, and we know the area to the left is 13. What's the 0.13? 19.87. They always want 2 places, usually. All right. 19.87. Round to the nearest whole number. So we could just say 20. Okay. We could just say 20. We could have done this in the calculator as well, in the graphing calculator. Would not have been too difficult. You simply go to distribute inverse norm number 3. The area to the left is 13, because that's what we mean by percentile. We're dealing with 21, and we're talking about the area to the left. We're going to get that 19.87 when you round it off to 20. Now they're talking about the inner 39%. All right, a graph would help. So the inner 39% is this, which basically means the 2 tails will make up the rest of the 100%. All right, that's 61, and if we divide 61 by 2, we get 30.5% and another 30.5%. The mean is still 21, the deviation is still 1, but what we need to do is find this value and this value. We'll call this the lower bound, and we'll call this one the upper bound. We need to find these two. The mean is still 21. Now, we can do this a number of ways. One way is we could just do inverse norm of 30.5, and we would get the lower bound. And then we could do inverse norm of 30.5 plus 39. The sum of these two, the area to the left, that's actually 69.5. That's probably the best way to do this one. So we'll go I'll do a second entry, and instead of 13, I'm going to do 30.5. And I know they don't want me to round it off. That was weird. They should just round it off to the nearest 10th, but that's fine. And the other one would be, we're going to add another 41 on top of that, or 39 on top of that, which gives us 69. So we went from 20.48 to 21.5. They want to round to the nearest whole number, so okay, 20 and then 22. It's kind of weird. All right, let's keep going. All right, Z alpha. The notation Z sub alpha is the Z-score that the area under the curve, the normal curve to the right of alpha is what? That's a good question. Now the notation, it has to do with alpha over 2, really, because alpha represents the amount left. It's just, and in fact, based on the problem that we just did too, that was pretty helpful in understanding this other one. So we had 39% was the innermost 39. The alpha would have been 61. And so little alpha, Z sub alpha represents the critical value, one of these. So you'd have to divide the 61. You have to divide it by 2. Let's see here. Yeah, it's a pretty good question, I guess. Let's keep going. Well, binomial probability. Okay, the calculator can do this. StatCrunch can do this. Just as it looks, you go into second, distribute again, go down to binomial, CDF, or wait, hold on. It's PDF. They gave us the exact A value. Trials is 60. Probability is 30%, or 0.3%. And the X value is 2. So we're getting 27.23. Now, StatCrunch could handle that problem too pretty easily. You simply would go over to your calculator and go choose binomial, and therefore you'd be able to enter that in there pretty easily. Find the z-score such that the area under the curve to the right is 0.42. There's a couple of ways to approach this. Let's look at a few. We're talking the area to the right is 42%. So the area to the left is 100% minus 42. That's what we mean 1 minus 0.42. That would be 58. The remaining portion is 58%. Because together they make 100. So that could do it right there. We could just do inverse norm of 0.58. Are we talking about the standard normal? Yep, it's the standard normal. So the mean is 0. The standard deviation is 1. You pull this on your calculator, you just do inverse norm of 0.52. you're going to get 0501. We could easily have done this on we could have done this on the StatCrunch as well. And let me just demonstrate that real quick. So to get to StatCrunch, all right, and to use the inverse norm capabilities, we will have to go into calculator and then go over to normal. We're looking for, let me see, the area left of 0.58, so I just put in 0.58. Let's see, the question was about. Yeah. So the right tail, that also splits it. So it is the area to the right tail of 0.42. Find the z-score such that the area under the standard number curve to the right is 0.42. We just did this one. It's the exact same problem. It's pretty strange. And this one seems like the one off. I don't know what this problem is doing on there. It's probably not that bad though. Alright, you're going to construct a discrete probability distribution for the random variable based on the data here. That shouldn't be too difficult. Remember the total number, and that's how many times it came up. 18 out of this amount. That's 45, and that's 85 altogether, so 18 out of 85. And we will get a probability distribution. They're decided to graph it in such a way so that you can actually look and see how the values of the probability is being distributed. And then you have to crank out the formula. Yeah, I don't know what this problem is doing on there. I should remove this one actually. But yep, that is a review of some things that we've been working on. Let me know if you have any questions or you want some more information.